Hey everyone, hope you're all having a great day. Hope you've all enjoyed your weekend. But it's Monday again, and we are now into week 2 of the Ink Hackathon. Again, as we've previously spoken about, we have a huge schedule with a lot of interesting workshops, and we will be continuing this trend with a fresh one today, which is going to be held by Piotr. One thing that I want to ask is, will the real Piotr please post something, because I have a couple. So Piotr, I know you have the proper invite for the event. That will be you, amazing, getting you onto the stage as we speak. And I hope you're not trolling and you are the real one, but yeah.
Can you hear me?
Yes, I can.
Perfect.
Hey. Yes, sorry for, again, there was a couple of Piotr, so I did not know who the true one was, but happy to have you here. Yeah, feel free to introduce yourself to everyone that's here and introduce the topic, and yeah, take it away.
Sure, thank you very much. Just let me know, let me share my screen and let me ensure that you see everything. Perfect, okay, so I think we're good to go. So as introduced, my name is Piotr Mikołajczyk. I am a blockchain developer at Aleph 0, as well as I'm also a core contributor to the Ink language itself. Today I'm replacing Mateusz as he couldn't attend today's session. But anyway, I will have a pleasure today to introducing you to the different testing strategies for Ink smart contracts. Now, during previous sessions, previous lectures, you have seen seen some examples and foundations how to write simple Ink smart contracts. Now, assuming that you have already implemented something, it is usually a pretty reasonable idea to test it, especially if there are some money involved in your contract. Then you really want to assure that its behavior, the contract behavior, is indeed correct and well, as expected. Now there are at least several methods or approaches that you can take, starting from the very easy static checks that are usually built in a compiler or other tools that will search for suboptimal snippets, or even will search for common vulnerability patterns. On the other side of the spectrum, there are very sophisticated and complex methods like fuzzing, which will test your contract against very, very different way, any type of traffic that can come to it. However, during this session, I will show you 3 primary testing strategies for Ink smart contracts. And these include unit testing, end-to-end testing, and a pretty fresh concept that is like 4 months old, which I personally like to call quasi-end-to-end testing. But before we move on to discussing every single of them and spotting the differences between them, we'll have to take a brief dive into an architecture of the environment where smart contracts are being executed. So let's start. Maybe just one remark. I will use the terminology and the architecture that comes from Polkadot world, or even to be fair, from the Substrate framework world. But all these facts, all this architecture is pretty universal, pretty generic, and it applies to probably at least majority of the blockchains that you can meet. So let us consider a full node, for example, a validator node that is trying to participate in a blockchain network. So essentially, a validator runs a binary. This binary is usually called a host or sometimes node, whatever. And this binary is responsible for the core tasks of the blockchain infrastructure. So primarily, this binary is responsible for the whole networking protocols, for gossiping messages, accepting some transactions, and sending and receiving new blocks. Also, this binary will run procedures or actions for building blocks, disseminating them, finalization consensus. Also, this binary will take care of storage management and connection to database and that stuff. Sometimes this binary will also be able to answer some off-chain operations like RPC queries or just state query. From time to time, this node will receive a new block, or just to make things simpler, will receive a new transaction to be processed. And in order to compute the new state, the updated state, this host will have to spawn an auxiliary process in order to compute the new state. So in Polkadot world and Substrate world, this thing that it has to be executed is called runtime. In other words, runtime is essentially a state transition function. So that means that this is a function that takes as an input the old state, the new transaction, and computes the updated state. Okay. For some reasons, this has to be spawned as a nested execution environment, and well, when the state is computed, then the host receives the result and can update its own indexes and storage. However, if the transaction that came to us is a smart contract interaction, like instantiation or smart contract call, for some reasons we won't get into that here, the runtime has to spawn yet another execution environment, a sandbox just for this contract execution. So just to recap the whole picture, the host is this main binary that is run by a network participant. When we get a new transaction to be processed, we have to create a new process for the state transition function called runtime. And if this transaction happens to be a smart contract interaction, we need to create even more nested sandbox execution environment to execute the smart contract. And well, if you were to dig even deeper, we would find more layers of this in this diagram. And this happens to be, I like to call it substrate onion or blockchain onion. So blockchain happens to be pretty complex, like onions. But to come back to how it relates to testing smart contracts, we can take a look at this technology stack that we've discovered. So on the left side, we have this three layers of the technology stack, starting with the host binary, runtime layer, and contract sandbox. Now, if we and depending on the suffix of this, depending on the top of this stack that we are considering, we can derive a different testing strategy. So, for example, if we want to test our contract just in this contract sandbox layer with complete isolation, with no runtime or host context, we'll end up with something that, it's just unit testing. On the other side, when our test will involve the whole stack, the full stack, then naturally it will be just end-to-end testing. There is a third approach, this quasi end-to-end testing, which touches only two innermost layers, ignoring host binary. We'll get to it at the end. Now we are having this picture in mind, which strategy relates to what part of the technology stack. We can move on to discussing every of these three strategies separately, looking at some code. Let's start with unit testing. if you remember the previous slide, unit testing touches just this sandbox, this contract sandbox, with no information, with no context of blockchain. So essentially, if you think about it, a smart contract is just a data structure with some public API, with some public messages that we can interact, by which we can interact with this contract. So this is just a software component, and unit testing is nothing more than component testing in a classical, in a standard software engineering. So let's have a look how unit tests of a smart contract look like. Can you see my code?
Yes, fully visible.
Yeah, perfect. So for an example, I will use pretty easy setting. So assume that on chain, on some blockchain, there is a game implemented as a smart contract, and we want to create our player contract. So we assume that we came up with some strategy for this game. We implemented our player as a contract, and then in the future we'll just deploy our contract and register it to the game. Hopefully we'll win something. Okay. Now, before deploying and registering our strategy, as I said, it's reasonable to test it, to verify that actually it works as we expected. Okay, so here is my very simple contract with some storage and just a single public method, my turn, which when called will return an optional coordinates, just to integer coordinates based on some internal state. Okay, so let's have a look at the unit test for this contract. So as I said, we cannot do much. I mean, what we can do actually is to test this module just as it is a simple Rust module with some structure, data structure, and some public methods. For this, we will use this macro from Inc language, Inc test. This is because if we go back to a contract definition, there are some decorators, some macros over our contract, and well, in order to work with our contracts just as a simple component, we actually have to use this Inc test macro to create a test case with our contract being orchestrated, instrumented as a simple Rust module. Sorry. So what we can do here is firstly assure that we can create our player contract with some initial arguments and assure that its internal state is valid as expected. So here we are just creating a new object of the type my player, and then we are asserting that its inner data is well as expected. And the second test that we can that we can do is actually testing this one single public API method for that will return coordinates for the consecutive turns. Now I have some auxiliary method check dummy playing, which will just take board size, I mean the entry arguments of the contract, and will just simulate off-chain the game and assure that our public method returns the expected coordinates, right? So here in this test case, I'm just calling this checking with different initial arguments and asserting that everything works fine. Okay, so basically that's all we can do here with unit testing. It's something, usually it is a very good idea to prepare some unit tests for your contract in a very early development phase. Especially unit tests are useful and helpful if some of your messages in jargon have some sophisticated logic behind. So, for example, if you are writing a contract which does some economic like swaps or computing something related to implementing some mathematical model, you probably want to test this part of logic in unit tests. It's completely okay to do it in isolation from the blockchain, and well, it surely would be very fast to run. Okay, so here we are with unit testing. Now we go to end-to-end testing. So in end-to-end testing, we are actually simulating full flow of interacting the on-chain contract. So in order to test the whole stack, for each test case, we'll have to spawn or run a blockchain behind. Let's see the code. Not here, sorry, here. So yes, here end-to-end tests. For this, if you want to create a end-to-end test case, we are using E2E Test macro from Inc language. This macro does a lot of job. Firstly, for every such test case, every function marked with this macro, a new blockchain node will be spinned off in the background. So when we are executing this test case, we'll be communicating with this background node, sending a transaction to it, and asynchronously wait for this transaction to be processed, and the result will be returned. So inherently, every end-to-end test case has to be asynchronous. This has we are simulating the real-world interaction, so this is as expected. However, it comes with some pain, but we'll get to it later. Let's see how a standard end-to-end test look like. And in the first test case, we'll just check if the instantiation of our contract works. So something analogous, something similar to a thing that we've done previously in the unit tests. So firstly, notice that our test case takes one argument, takes one input argument, which is a client, end-to-end client, which is able to send our intentions, our transactions to this background node. Okay, so firstly, we'll have to send a transaction to the node that we want to instantiate a new contract using this origin, this account, with some constructor wrappers. So here, end-to-end framework from Inc gives us some wrappers for our contract to build with a call object, right? An object that encodes our intention for invoking a constructor with appropriate arguments. So to our client, we will pass this constructor object, some additional information like how much tokens we want to transfer with this to this new contract with this instantiation transaction, and also there are also some other arguments like storage deposit limit and possibly some other things. Once we create this instantiation intention, we pack it to a transaction. The transaction is asynchronously sent to a background blockchain, background node. If it's then we asynchronously wait for the results. So we wait until this transaction is packed into a block. A block is built, finalized, and processed by a node. And then once the state is updated, the node will let us know, and then we can assure that everything everything went fine. The first observation that you can make here is that there is much more things going on here than compared to a unit test, right? This is because we are talking with a full stack, which includes both runtime part and this node binary. Okay, so what we can do next? Of course, we can do the same as with the unit tests. So we can assure that our deployed contract, uses this strategy correctly, as expected. So firstly, we can instantiate our contract. Here I put this whole boilerplate into an auxiliary function because, well, we have just seen what it does. And now we can make a sequence of calls to our deployed contract and checking the returned value. So as before, we are creating an call object for this particular call that will be sending, and well, here will be simulating a game. However, this is not a perfect simulation, right? We are not using a game contract. Here we just simulate this game completely off-chain, right? We'll make a sequence calls to our contract, and we are just pretending that we are playing. And for every turn in our simulated game, we'll call our contract with this call object that invokes my turn public method, our contract. We are specifying some other auxiliary arguments like how much tokens we want to pass or what's the storage deposit. And then asynchronously we wait and ensure that the returned result is as expected. However, all these things that we have just seen and done could have been done with unit tests. So what's the game? Well, let's go to the next test case when you will see the full power of the end-to-end tests. So here we can see that we can enrich this macro invocation with additional contracts argument. So this tells this test engine that's behind the macro that in order to run this test case, we have to compile also some other contracts. We'll actually make in our test case, a few contracts will interact with each other. So now we are not testing a single component, but instead we are testing a whole suite of our components, a whole system of components. So firstly, this argument ensures that a game contract is compiled before running this test case, and we have already some access to the compiled bytecode. And now we can simulate a one-player game. So in this test case, we'll deploy both game contract and the player contract. We'll register this player at the game contract, and we'll actually trigger game contract to run the game. Okay, so here we see that we are instantiating my player, instantiating game. Game instantiation is very analogous to instantiation player. And now when we have both contracts deployed, now we can register our player. So this will be a call to a game contract. And now we can start the game. So firstly, our game API requires that we call a start game message. And then in some number of rounds, we are calling the game contract to submit a new turn here. And after enough number of rounds, we can ensure that the game is finished, and our player has won. We can go even further with such simulation. We can simulate the whole game with other players. I mean, we can check how our strategy, our contract, works when it plays against some opponent different strategies. Okay, for purpose of this presentation, I've implemented two other player strategies. One is called random player, and the second one is corner player. This is the corner may make sense if you would dive into how game looks like. So in this test case, we are instantiating game as well as all 3 players. Then we are registering all strategies, all 3 strategies, and then we are simulating, we are calling a game contract to run turns. And once we have played the whole game, we can finish it and then ensure that that the state of the game is finished with some winner. Since we are using a random player, we cannot be sure who won, but well, we can at least ensure that the whole game went successfully and is finished. Okay, so basically, this is with end-to-end test. We can test anything. We can simulate whatever scenario we need, and well, actually, it gives us a perfect simulation, a perfect dry run of our contract. However, this comes with some downsides. Remember that behind the scenes, in the background, there is a blockchain running. So every transaction that we are sending to this node, to this blockchain, has to be packed into a block has to be built, finalized, and so on. So we actually have to wait for all the natural operations for a blockchain. And just imagine that our blockchain, for example, Polkadot, has a block time of 6 seconds. So in order to, well, make a few consecutive calls in our test case, we'll have to wait 6 seconds for every another call, just because we have to wait for the previous call to be executed, and well, we have to assure that it succeeded. This makes things way harder if you want to, for example, simulate our contract, or want to simulate some economy for, say, 2 months, right? Because if you want to simulate how our contract works in a 2 months window, we actually have to wait 2 months, right? So this is not very friendly for us for a fast development or even CI/CD pipelines, right? Well, there are the picture is more problematic. Let me go back to a slide. I have done some end-to-end testing during last years, and I've tried to list all the pipeline steps where I had some problems, and I ended up with a pretty long list. And as you can see, some of these steps occur. Some of the problems occur on the client side, on the test client side. Some of them happen on the node blockchain side. Some occurs on the runtime side, to be more specific on this contract sandbox layer. However, problems can occur anywhere here, right? So it can be pretty overwhelming. But well, the truth is that once you have your testing environment set up properly, most of the things will just work. Especially all the things that happen on the node side. So after some time, some playing with your local Docker networks, spinning up your node, you can be pretty sure that there will be no problems on the node side, and that's the background of the idea that I came up with like in June, like 4 months ago. Well, let's try to extract things that are really that really matter in an end-to-end test scenario for a smart contract. And if you think about it, there are only three steps that should matter, that we should take care of. So firstly, we have to prepare the input data, right, the transaction data. Then we have to ensure that the contract execution itself happens correctly. And then we have to assure that the state after our call is as expected. So simplifying the slide, there are only 3 steps. Given data, when the smart contract is executed, then a state should be like this. And none of these steps happen on the node side. They are happening either on the client side or in the runtime smart contract smart sandbox. So the idea for this is to just ignore the whole node layer. So what we want to do is we want to interact directly with the runtime, so with the top 2 layers of the technology stack, and we are just ignore. We don't want to run a blockchain for our test cases. We are working with just state transition function and smart contract sandbox. Having this idea in mind, I have prepared a library for that. It is it's called Drink library. Drink is an acronym from Dechained, Ready to Play in Playground. You are very welcome to visit the repository. It comes with 2 products. The first one is a simple terminal user interface, so a graphical tool that you can play with locally with your contract. So you can deploy to a local runtime and interact with these contracts. But the most important part of this repository of the whole project is the library itself, the Drink library. Let's have a look at how you can use it to perform this quasi end-to-end testing. Why quasi end-to-end? It's as I said, you probably won't meet with problems on the node side when testing your new smart contract. So it's like almost end-to-end, but well, we are ignoring this node layer, so it's not a full stack testing. But still, it's pretty helpful. Let's see some code for that. So just a remark here. Please notice that since we are not using any node, any block, there is no blockchain running in the background, everything happens in memory. So inherently, all these test cases happen synchronously. There is no block time waiting. There is no asynchronous communication with some other process that you have just run in the background on your machine. Everything happens completely locally. So let's see how things look like with Drink for our smart contract. So firstly, let's see how this instantiation test case will look like. Firstly, we will have to use some transcoder, so something that translates arguments, like weakly typed arguments to a proper encoding. We will just see in a minute. Just to notice, this project is pretty fresh, pretty young, so there are some onerous things, but still we are working on improving things. So please be merciful here. So now we can create a session. Session is basically an object that holds this in-memory runtime, and we can interact with our contract with the whole runtime itself through this session object. And now we can ask our session to deploy the bytes, the bytecode of our compiled smart contract. We pass the name of the constructor. We encode we encode the argument, the contract arguments, and then that's all. We are just ensuring that deployment went successfully, and that's all. Next test case is ensuring that our dummy strategy works correctly. So again, we are creating a session, which will create a in-memory runtime. Then we are instantiating our player, and then we are just ensuring that our coordinates, that the return coordinates are as expected, right? Please notice that here we are not using any ink-specific macro, we are just using Rust tests framework. With Drink, we can do pretty much the same as we've done with end-to-end testing. So that's completely not a problem to test multiple contracts. So for example, we can simulate the game with many players. Sorry for this. So now with our session, we are deploying all contracts, all 3 players, and the game contract itself. Then we get the addresses of these contracts just for the registration. Then for our session, we are registering our contract, our player contracts, and then we are playing the game. We are simulating it, and in the end, we are querying our game contract of its state. We are ensuring that it has finished, and there is some winner there. Okay. That's all. That's how drink tests work now. There are some features that are to be announced soon. For example, there is an open PR from the last week that actually in Drink library, in this Drink framework, you can mock your contract. So before Drink, there was actually no way to do that. You would actually have to create for every mocked version of your contract. You would actually have to build a new contract, compile it, and use it. Now there is a pretty easy, there will be pretty easy API for mocking it. It's just in a review phase. So well, that was drinking thing. However, here there's one very positive information, right? Because what we have just seen, there are 3 different frameworks for tests, and well, as of boilerplate, if we would want to use every single one of them. So, well, for the last 2 months, I think, in Inc, together with Inc, with other Inc core team members, we are working on integrating Drink library with Inc language itself, with the Inc language framework for end-to-end tests. And as a result, you can write a single test content, like here. So we have our test logic in one place. There's just one code here, and with another macro argument, we are choosing whether this test case should be run against the full stack, so like a typical end-to-end test, or should it work with Drink engine behind, so completely synchronously and, well, much faster, right? Just a very important notice here. I've said that Drink tests are faster, so that there's no block time. So if you want to simulate your contract economy for 2 months, it will just work as fast as your machine, because there's no need for waiting to blocks to be built. However, of course, just before the deployment of your contract, you really want to run end-to-end tests. So to assure in 100% that your contract works perfectly with the whole stack. Okay. However, now it is very easy. You can have just one suite of your test cases and just switch this macro argument, whether it should run on Drink backend. So, for example, for a local development or in a fast CI pipeline, or maybe it should run on the full stack in a nightly pipeline or just before deployment. Okay. So the key takeaways from this presentation is, of course, always test your contracts. No matter how onerous it might look like, it's always a good idea. It's a reasonable thing to test it. Now, which test strategies for what things? As I said, unit tests are very easy to write. They are very fast to run, so they are perfect for the initial development phase. And usually, this is completely sufficient for complex methods that will perform some computation behind some non-trivial things. So unit tests for these tasks. Drink, this nodeless approach is good for development phase, for your local play, and for things like long run simulations, right? So if you want to check something for in a very long time window, this should probably give you sufficiently good estimate. And of course, as I said, end-to-end tests are a must before deployment, but they can be added, they can be run in the last phase of your product development. That's probably all for me for now. Are there any questions that I can answer?
There are a few comments in the chat if you want to have a look.
Sure. Let me see. I have a single screen, so sorry.
Yeah.
Is ink test a trade? No, both ink test and ink end-to-end test are macros. So they are very similar to so they are very similar to this standard Rust macros. This is standard Rust macro for a test case. However, ink test cases have to be marked with this ink specific macros. Marker. Sorry. Yeah, probably that's my fault. I should always use macro term for that. Are there any other questions? Yeah, the trade-off is the trade-off is like the basic thing is that we are losing this blockchain stack, so we are not performing a full simulation. So, for example, if your contract uses some things from host process, host binary, we'll see tomorrow how it can be done, then you might end up with problems. However, for most contracts, you won't see a difference actually in a test result. Memory-based runtime would be much faster. However, still, as I said, you should run end-to-end tests in the final phase, just to be sure and sincere with yourself that you have tested your contract against the full stack. Validity of a test. Yes. Okay. The thing is, okay. So let me go back to a test here. Yes, that's a very, very, very important thing to have in mind. Please notice that I have created the session object with a minimal runtime, and minimal runtime is actually a runtime, a substrate runtime, which is completely minimal, a minimal runtime that allows for smart contract execution. And if you are targeting a real chain like Kusama, Aleph 0, Fala, Astar, you should really use this runtime, the target runtime here. So for most contracts, you won't see the difference, but some contracts, for example, like liquid staking or some economy-related one, will use a particular features of a runtime. And you really want to ensure that you are using a target runtime, because unless so, you might end up with a false positive or true negative or whatever, right? So this is a thing to have in mind. The very similar thing happens not here. Sorry, for an end-to-end test. So if you are running end-to-end tests like this, the node, the blockchain that will be run in the background is a default one for ink. So it is called substrate contracts node. In your real test, you should change it via some, I think, environmental variable. You should point this backend to your real node, to a Aleph 0 node, Astar node, whatever, right? So this is the same thing to keep in mind, that you should use the backend, the engine that you are targeting. This is Rust Rover preview, and that's why I've got some of these red labels about internal errors of the IDE. Sorry for that. Right. So this is
Last question coming in. Yeah.
let's see. Right. So Drink is integrated into Ink end-to-end framework. So that gives you this speed up of running tests without Node. But Drink itself, as a library, comes with much more features that a testing framework from Ink gives you. So, for example, as mentioned, this mocking thing, this is usable only if you are depending on the Drink itself, just directly taking a Drink library as a dependency of your testing. So, in that sense, it makes sense to work directly on a Drink library, some enhancement on top of it, and so on. So, as I said, just last personal remark, you're very welcome to test this Drink library. Be merciful because it's very fresh, but I would be very, very grateful for any feedback, any input, issues, whatever you find there. We'll be glad to develop it and fix bugs. So, right. So I guess that's all.
Very good. Thank you, Piotr, for this one. And again, for all of you, I hope this one was an interesting workshop. Thank you, Piotr, for covering. And yes, there will be another one by the end of the day. So feel free to tune in roughly 40 minutes. We'll have another workshop. And Piotr will be back tomorrow for another workshop as well.
That's right.
For interaction with Ink smart contracts and the environment, if I recall correctly. Yeah. Yes, again, thank you all for being here, and see you all in a bit later. Enjoy the break.
Thank you very much. See you. Bye.
See you all.